Okay, so for 9.1 inverse variation, and we're looking at how do variables relate. We looked a little bit at this in chapter 2 when we talked about direct variation. So we should know direct variation, y equals k times x, where k is the constant of variation. Now we're on to look at inverse variation, where y equals k divided by x. Okay? K is still considered the constant of variation, and the rule is k cannot equal 0. Okay? Positive, negative, that's fine, but it cannot equal 0. Okay? What you're going to have to do for some of these is ask to find the equation. It kind of shows the equation that how y and x are related to each other. We're also going to have to verify what kind of variation two values have. So we're going to be looking at one example. X and y vary inversely. X is 4, y is 8. Write an equation that represents their relationship. The important part here is inversely. As soon as you see that these two variables vary inversely, you need to be thinking of the equation. Y equals k divided by x. Now it gives us our x and our y. What we need to find is our k. So our x ends up being 4, our y is 8. And there's an equation we should be able to solve. Okay, solving for the value of k, multiplying 4 on both sides, k equals 32. Now it asks for, write an equation that represents the relationship. So I don't want to just see k equals 32. Finish by putting it as y equals 32x. Okay, 32 over x, sorry. Okay, another example, x and y vary inversely. X is -2 and y is 14. And it's asking the same question. Write an equation that represents the relationship. So again, inversely. As soon as you see inversely, y equals k divided by x. Okay, and the same process. We know our x, we know our y. Okay, taking those two values, plug them in. 14 equals k divided by -2. Multiply the -2, k equals -28. Okay, so we have our constant of variation is -28. Y equals -28 over x. So that's finding the equation that shows the relationship. It tells us that for every x value, this is going to happen to y. Okay? Y equals 32 over x, y equals -28 over x. Now, this is a problem that we looked at in chapter 2. Identify direct variation from a data set. Does the table show direct variation? And if yes, find the constant variation. What we looked at here was if we know this is direct variation, or no, that's what we want to solve for. We know direct variation is y equals k times x. Okay? So to see if this is direct variation, that means for each one of these relationships, the constant is going to be the same. That's why it's a constant. To find the constant, divide both sides by x, and we have y over x equals k. So if that gives us the same value for k for each one of these relationships, then it is direct variation. So we can do 8 divided by 2 is 4. 12 divided by 3 is 4. 20 divided by 5 is 4. Since each one is 4, this is direct variation, and our k equals 4. So that would be our constant of variation for this. Okay? So that was something we did back in chapter 2 with direct variation. Now if I ask you the same type of question, but this time with inverse variation, well, let's think about what the equation for inverse variation is. We have y equals k divided by x. So if we're looking at what k is, multiply both sides by x, xy equals our k. So in this case, now we can take this and look at what k is or what k should be by doing x times y. So for each one of these, we should be able to multiply these through. Okay? If we multiply right across, 0.2 times 12, okay, that should give us 2.4. 0.6 times 4 gives us 2.4, and 1.2 times 2 equals 2.4. So again, they all equal the same thing. We have K equals 2.4. So there's our verifying inverse and direct variation by table. Okay, there's the question. Now we have identify direct and inverse or neither. So now we're going to be looking at different relationships and not really saying, okay, verify if it's direct, verify if it's inverse. I'm just going to give you the table and say, find what kind of variation it is. So we have, in this case, x, y. We have x being 1, 2, 5, y being 4, 7, and 16. Now what we need to think about here is, what direction is the y going as x is increasing? Right? That's going to help you identify if you're on look for either direct or inverse. Think about what direct is. Y equals k times x. And as that x is increasing, what's happening to the y? Well, if you think of the equation, or sorry, think of the graph, direct variation is going to be increasing. So as x is going up, y is also going to be going up. If you think of inverse, okay, y equals k divided by x. You have to know how fractions work. Think about how fractions work. As that denominator is getting bigger and bigger, what's happening to y? Well, in this case, as x is getting bigger and bigger, y is going to be decreasing. As that denominator increases, the fraction value is getting smaller and smaller. If you think of this graph, okay, if you would graph an inverse function here, this is on the exponential decay. Okay? It gets closer and closer to the x value here, or the x axis there. Doesn't ever get to 0 in this case unless we're on move it a little bit, but it is decreasing. So as x is increasing, our y is getting smaller and smaller. So that's how you're going to be able to tell which type of variation are we going to look at. X is increasing, y is increasing. So since they're both increasing, we know we're looking for direct variation. Now, we're not going to decide yes it is direct yet. Now we have to test it. Remember, to test it, we're going to look for y over x. Okay? If all those are the same, then yes, it is direct. 4 over 1 is 4. 7 over 2 is 3.5. No need to do the third one. If they're not all the same, it's not direct variation. Since the first two don't match, it's neither. It's neither direct or inverse variation. Okay? Let's look at both these here. We have, for the next one, we have x is 2, 4, and 8, and we have 3.2, 1.6, and 0.8. So this time we have x is increasing, 2, 4, 8, but y is decreasing. It's getting smaller. So we're on a test to see if it is inverse. So for the inverse, to test for this one, we're looking at x times y. If that's the same all the way through, then yes, we're going to be okay. Okay, so looking at this, we're going to have 2 times 3.2, that is 6.4. 4 times 1.6 is 6.4. And 8 times 0.8 is 6.4. They're all the same, so yes, it is an inverse function, and our k is 6.4. Okay, and the last one over here, we have x is increasing, 1.2, 1.4, 1.6, and our y is increasing. So since it's increasing, x is increasing, y is increasing, we have direct variation. We're going to check our y divided by x. 18 divided by 1.2, and that should be 15. 21 divided by 1.4 is 15. 24 divided by 1.6 is 15. So they're all 15. Yes, it is direct variation. K equals 15. Okay, so there's verifying. Think about X and Y, how they related. X increases, Y increases, it's direct. X increases, Y is decreasing, it's inverse. And the last thing we're going to look at is different types of relationships that we could have. Okay? We have our, for A and B here, we have our two basics. Y varies directly with X, Y varies inversely with X. Okay? The variable that's by itself on the left-hand side, what is it equal to, is going to come first. Y equals K times X, Y equals K divided by X. Okay? That's going to be the same for these other three examples that we have here. For C, Z varies jointly with X and Y. That jointly there, that jointly is another way of saying we're going to multiply these variables. You can see Z varies jointly with X and Y. Z's by itself, and it's X times Y times the constant of variation. You don't talk about the constant in these statements. The constant is going to be there. It's what variables are being multiplied or divided by those constants. Down here we have Y varies inversely with the square of X. And this is just doing the inverse. It's the same property, but it just has the X as being squared. It's not just X anymore. It's having a little more to it. And the last one, Z varies directly with Y and inversely with X. So here's just putting the two together. Z equals K times Y. Well, that's where the directly comes from, directly with Y, divided by X, inversely with X. Okay, so you're just putting both the inverse and directly together. Now, what you're going to have to do is kind of look at these and see how we can put those together. How can we put these variables and how are they being mixed together with all these statements? Always remember you're starting with the variable that's by itself. So if we're looking at two examples here. We have M equals 7EF. So think about what's happening. Our constant is 7. That's what you need to be able to identify. And it's being multiplied by E, multiplied by F. So if I'm writing this out, I'm going to start with M by itself. M varies jointly with E and F. Jointly because it's being multiplied and it's more than one variable. So use it jointly when there's more than one variable being multiplied. And it doesn't only have to be 2. It could be 3, 4, 5, however many variables you have. It could be M equals, or M varies jointly with A, B, C, D, and E. However many variables you have. Here we have Z equals 4 times X squared. So times is going to be directly. We have Z over by itself, and we have to remember we also have the square there. Z varies directly with the square of X. Okay? So that's on B9.1, that's inverse variation, kind of going back to a little bit of chapter 2 with direct variation. So that's it for 9.1.